Okay, so let's test this out and see if we get a decent video. I have first of all, a topic that was that was requested from a student called, and you can't read this maybe on your screen, understanding the relative energy of rotational conformations. This is a topic that's due tonight, and it's a little complicated. So of course, right? So what I did was I went over to Mastering. Let's see, I think it's called Mastering Organic Chemistry. Probably the best tutoring website for organic chemistry on the internet. And I screenshotted this energy diagram. So here's what's going on. Let me show you. What this guy has done is he's built an ethane. So I've got an ethane here, right? Can you see that's an ethane? Let's go back here. Can you see that? A little bit busy here. Okay, so I've got 2 carbons. My fingers are on 2 carbons. My fingers are on carbons. All right. And then I've got 3 blue sticks coming off of each carbon, and they are rotating, right? That's what ethane does. So in this first one, you see this? It's eclipsed. What he's done is he's drawn the energy of that structure right there. Can you see that? Okay. Can you see what I'm doing here? Right. So this is eclipsed down that angle here, right? And I've got 2 hydrogens, if the blue sticks are hydrogens, right? Okay, that's the energy of that. Well, as this thing rotates, the energy goes down, and that's the lowest energy, called staggered. You probably already got that from your homework, all right? That's staggered, and can you see as it rotates 60 degrees, this is 0 degrees, 60 degrees, 120 degrees, 180, right? Okay? And as it's rotating, the energy is going down and then back up because it goes from eclipsed to, whoa, staggered. That's awesome. And then it goes back up to eclipsed as it keeps rotating, right? Staggered, eclipsed, and so on. It's going up and down. Well, the structure that you're asked to evaluate in this topic is not, I hope this is recording, is not ethane. It's more complicated. What this is, looks like it's dibromochlorine. Okay, so dibromochlorine. So let's say that the bromines are the biggest. The bromines are the biggest, but they're both on the same side. Okay? The bromines are the biggest, but they're both on the same side. So let's let one more black stick, I guess, right? Let's let these be the bromines. Let's let red be bromines. Okay, and yellow will be chlorine. And so that'll be bad because we got a chlorine atom. This is going to be high energy, right? Chlorine atom and a bromine atom. That's lower energy, but not great. Higher energy again, lower energy, and that's the also high energy, but this is a hydrogen now, right? You see what I've got here? I wonder if you can tell that's yellow. There's a hydrogen, and then lower energy yet. This is probably the lowest of all, because that's as far as we can get the yellow away from the 2 reds. I mean, that's further yet, but it's eclipsed with a hydrogen, right? So that's lower, and that's low, but it's because it's staggered, but it's between 2 bromines, so it's not the lowest. All right. So now that I've got that appreciated, you can see that we got 2 that are lower, and it's low, but not the lowest. Got it. I can do this now. All right. So this is ending up to be a bit of a long video, but okay, so draw the Newman projection for a conformation of 1,1-dibromo-2-chloroethane, which I've built, and that really helps, that has the relative energy described by point B. All right, so it looks like this is the 2 lowers, and this is between the 2 lowers. So the 2 lowers, the lowest, that's going to be one of the lower, because it's as further away, as far as it can get away from one of the bromines, right? That's as far away as it can get from the other bromine. And so this is the high between the 2 lowest, and it's going to look like that. Oh yeah, you see that? Okay, watch. This is high, highest, because it's bromine against chlorine. Low, but it's between the 2 high. There's highest and there's highest, and that's between the 2 highest. So though the two highest looks like they're D and F. So between the two highest is E, right? There's one of the highest, right? And then that's low, but not as low as it could be, right? Wait, no, that's about as low as it can be. Yeah, because it's stacked, because it's away from that, right? So that's as low as it can be. That's C. And so that's going to be B. Looks like it's going to be. So I'm going to draw that now. Let me draw that now. It's eclipsed because it's one of the higher ones. It's eclipsed, and I'm going to put this to be chlorine, and this to be bromine, and this to be bromine. Nope, sorry. They got to be on the back carbons. The chlorine's got to be on the separate carbons, right? Hydrogen. This is going to be a long video. Hydrogen. But shorter than we're doing it in class. Because in class, I'm stumbling around, right? Solve. And that's going to be right. Because it's between the two lowest. But it's the higher one, so it's going to be eclipsed. Solve. Okay, I'm going to do another one. After I get credit for this, I'm going to do another one. Ah, hit solve. Doggone it. I'm supposed to hit check. Well, notice it didn't change, right? The two bromines are down. Let's hit check. All right, let's try another one. And here's a bromine with two, I guess, two carbons on the other side. Oh, two bromines. Let's keep those two bromines. And it looks like it's got two methyl groups on the other side. So what I'm going to do now is I'll use black sticks for the two methyl groups. Okay, and before I even look at the answer, I'm gonna say what's going on here, okay? That's gonna be the worst, right? Because I got two if the blacks are methyls, can you see that? The blacks are methyls, and the reds are bromos, and the white and the blues are hydrogens, right? So that's gonna be the very worst. There's gonna be one peak that's the highest, and it's C, okay, right? You see C is the highest of all those, and so B is gonna be like that. And the lowest of everything, oh, I don't know, that's going to be the lowest of everything is going to be that, right, where I've got the big guys away from that. Okay, so finding the lowest is going to be there. Finding the highest is the easiest thing. Okay, yeah, I'm sorry. The highest is where the reds are eclipsed with the that's going to be C. I don't know if I said that right. That's going to be C. Okay, that's because because the carbons are eclipsed with the bromos, both of them, both 2 and 2. So that's going to be on either side of C, which is B or D. Right? You see it's symmetric, so it doesn't really matter. Okay. And then I go up one more. Okay, that's it right there. That's going to be my answer. Okay, so I've got one methyl group, which is eclipsed with one hydrogen. Okay, and one methyl group, which is eclipsed with a bromo. Okay, so I'm just going to put this down here like that. I'm going to put it on my desk, and I'm going to look at it. It doesn't matter which one I do. So I'm going to do the bromines in front, because it's easier for me to see. I'm going to draw it like that. The bromines are going to go in front, and it's eclipsed because it's higher. So it's eclipsed. And I'll put the bromines here, Br and Br, and then the other one is hydrogen. Okay? And these are not both eclipsed, so this is going to be a methyl group, CH3, and CH3. And this is going to be a hydrogen. Okay? And I've done it with a model set, so I'm really confident. I'm going to click, what? After all that trouble, oh, it's 2-methylpropane. 1, 2, 3. Wait, but still the same. 1, 2 dibromo. Well, how did I get that wrong? Did I write something backwards? Bromo, CH3, CH3. I'm going to click and see how I got that wrong. Oh, it told me what carbon to write in the front. It looks like I was supposed to put the carbon 2 in the front. Back to the question. Draw the Newman projection. And I'm supposed to be looking from carbon 2. Oh, look at that. Okay. Okay, so if I turn this thing around, back to the question. Same one. And I'm supposed to be looking at from this direction. Okay, got it. So I can't just draw whichever carbon in front I want. I'm going to do this to CH3s. Okay, I'm going to leave that mistake in this video because I honestly think that's going to help somebody. Bromine and bromine. Okay. Check. And I'm going to get credit for that. Okay. All right, I'm going to do one more to try to regain my dignity. And whoa, different understanding. Okay, got it. So I've got a different issue here now. All right. So this time it tells me what to build, and it looks like I've got two. I'm gonna go ahead and build it. 2 bromines. Okay. And 2 methyls. Oh, it's the same one as I got here. Okay. 2 bromines and 2 methyls. Okay, now it's telling me what to oh, this is even better because I can this is what I'm going to do. Okay, look, here's the camera. Here's my 2 methyl groups coming down and a hydrogen coming up. This is the top panel. I'm looking at this panel here. Okay, 2 methyls and a hydrogen coming up. And then my bromines are going to be ones with the, oh, this is already correct. 1 bromine is eclipsed, right? And 1 bromine is eclipsed. 1 bromine is eclipsed with a hydrogen, and 1 bromine is eclipsed with a methyl group. By the way, it's the same as if I do that, right? I've got 1 bromine eclipsed with a hydrogen, 1 bromine with a methyl group. Doesn't matter. Now, it's asking me which would apply here. Based on the energy diagram, which point or points? Relative revolution. All right, so it looks like there's going to be more than one. Okay, so I'm going to go with the highest first. Again, because that highest is easier for me to see. The highest is when I've got the 2 methyl groups, two methyls in front, eclipsed with the 2 bromos behind. I wonder if you can see that. Okay. Probably should get like a white background so you can see that better. Okay. All right, that's the highest. That's going to be D. Only D. And it looks, I can see the bottom panel. That's what's going on here with the bottom one, right? That's going to be D. Okay, but now if they're eclipsed, but if they're eclipsed, but one of the bromines is eclipsed with a hydrogen, then it's going to be B or F. B or F. Right? And that's it. Okay. Because I'm only asked about these 2 conformations here. I don't care about these other things. Check. And that should be good. All right. Okay, long video, but I hope that's helpful. Appreciate the question from the student. Keep the questions coming. See you soon.